Well, sometimes people are wonder if certain foods will affect the gender of a baby. So researchers asked women about their eating habits, and they were looking at 133 different types of food and whether they regularly or did not regularly eat that food. So, if you have 133 foods studied, a hypothesis test is concluded for a difference between the mothers and that conceived the boys and the girls in that proportion based on the food that they were eating. So let's go ahead and state our null hypotheses, our alternative hypotheses, and if there's no difference, about how many significant differences would we expect? As in, if they were all true, is it possible that some of these are going to still come up as statistically significant? Now, it was also stated that the significant difference found for breakfast, those that ate breakfast cereal, the mothers of boys who eat, if I can talk here, sorry about that, mothers of boys eat more cereal, gave us this headline. So, what's going on with this headline? Well, looking at our null and alternative hypotheses, the proportion of the boys and the proportion of the girls should be equal. Our alternative is that they're different. There was no indication saying that one should be greater than the other, so that's why it's a not equal to. Now, if there were no differences in our null hypotheses are all true, how many statistically significant differences should we be expecting? Well, we had 133, and we're looking at our alpha being 0.05, we would expect about 6.65, or between 6 and 7 statistically significant differences showing up, even though all the null hypotheses are true. So how would you explain this right here? Well, by random chance. We would expect 6 or 7 of them to be true, even if um, there's no differences that exist. Out 6 or 7 to be true or statistically significant based on our 133 tests that we were doing. So when multiple hypothesis tests are being conducted, the chance of getting at least one test that incorrectly rejects our null hypothesis increases as the number of tests increases. So if all the null hypotheses are true, alpha will yield statistically significant results just by random chance. So consider a topic that's being investigated by research teams all over the world. In other words, there's lots of research teams all over the world going ahead and investigating this one topic. Well, using a 5% level, some of those teams, because there's so many of them investigating it, are going to get your statistically significant effect, rejecting your null hypothesis, even though it's true, just by random chance, just because there's so many people investigating that same topic. So consider a company who's doing hypothesis testing. Lots of hypothesis testing. They're going to go ahead and get about 5% of the tests to be statistically significant just by random chance, even though the null hypotheses are true, just because they're doing lots and lots of tests. So this is a serious problem. But for the most part, you just need to be aware of it because it's kind of beyond the scope of this class. Now, a small other thing is publication bias. For the most part, publications only want to publish stuff that's statistically significant. That's the stuff that is noticeable or newsworthy. Well, If it's not statistically significant, they're not interested in publishing it. But those results are probably done by somebody out there. So if it's statistically significant, people want to publish it. If it's not statistically significant, and maybe a lot of the studies on this one topic weren't statistically significant, they're not going to get the publication and be noticed because they only want to have significant results being published. So this publication bias compared or and combined with the multiple comparisons can often lead to misleading results. So to summarize this section, if your null hypothesis is within the 95% confidence interval, then you would not reject your null hypothesis in a two-tail test. If your null hypothesis is outside of that 95% confidence interval, then you would reject your null hypothesis in a two-tail, a not equal alternative hypothesis. Just because it's statistically significant does not mean it's practically significant. And keep in mind that just because something's being tested doesn't necessarily mean it's going to be correct, because 5% of all your tests are going to be rejecting your null hypothesis, even if they're all true.